Good morning, my dear students. My name is Twayna. I am currently available at the Hamlet Tuition Center, Brahmatal, Kathmandu, and the Kumudini Secondary School, Kalimati, Kathmandu. If you want to contact me, my contact number is 9849-135739. My dear students of grade 9, this is your science class, and in your science class we have been studying about the lesson electricity and magnetism. Well, last time we discussed about geographic meridian and magnetic meridian of Earth, and we also discussed that geographic meridian and magnetic meridian, they do not coincide to each other because the magnetic poles and geographic poles do not lie at the same place. Okay, so you can see the magnetic meridian and geographic meridian, they make some angle, isn't it? You can see that magnetic meridian and geographic meridian, they make some angle. Okay, and this angle is known as the angle of declination or angle of declination. Okay, the angle of declination is defined as the angle between magnetic meridian and geographic meridian. Okay, the angle made by magnetic meridian and geographic meridian is called angle of declination. And you should also know that this angle of declination, it changes with time. Okay, estimated, I don't have the exact data, but in around 1 lakh years, that is 100,000 years, the magnetic pole reverses. That means now this is north pole, this is magnetic south, and this is magnetic north. Yes, so after that time the pole will reverse. This will be magnetic north and this will be magnetic south. That means the compass shows that this is south pole and this is north pole. The pole just reverses. Okay, let's not go over there. We just understand what is the angle of declination. Okay, so angle of declination, actually there is no exact device to measure angle of declination. Okay, this is calculated just by using graph. However, the knowledge of angle of declination is very much important in finding out actual direction. Actual north and south direction. Yes, because your compass in general shows the north and south direction based on magnetic poles. Okay, your compass shows north and south direction based on magnetic poles. So even if actual north direction is here, the compass will not show it there. Okay, the compass will show it little bit offset. Okay, the compass does not really point to actual north. We should know that. So since the compass is showing at this this as north, we should not blindly follow this line, because this line is not actual north. This line is not actual north. Okay, you need to subtract or add based on the location. You need to subtract or add the angle of inclination for that particular place. Okay, so only after subtracting or adding the angle of inclination you will get actual north. Let's say in this example, angle of inclination of particular place of a place is 20 degree. It is 20 degree. Then what you should do is you must align the compass needle and the north pointer. This is actually printed, yes, printed on the floor of compass. Okay, so you must make a suitable angle of 20 degree between the compass needle and the north mark. You must make it. Okay, if you rotate the compass slightly, so that the north pointer, the compass needle, north of compass needle would actually coincide the north pointer in compass, then you will not get actual north. You will not get actual north. Okay, to measure actual direction, you must know the angle of inclination of that particular place. Okay, in some place you might have to do -20, in some place you might have to do +20. Well, that depends on which place you are in. Okay, any confusion? Like this is magnetic meridian, isn't it? This is geographic meridian. If you are at this position, then you have to add 20 degree, isn't it? Or if you are in this side, then you have to subtract 20 degree, like that. Okay, see, it is important to know the angle of declination of a particular place because it helps to find out actual geographic direction. A compass always responds to the Earth's magnetic field and responds to the magnetic meridian of the Earth. We, for our daily life, for our several purposes, we actually need to find geographic meridian, but our compass only shows magnetic meridian. Okay, so if you want to use compass exactly and accurately, you need to know the angle of declination so that you can get actual direction. Okay, that's all about angle of declination. Now let's go to angle of dip, or also called angle of inclination. Well, if you if you tie a bar magnet exactly at the central point and you suspend it, you might have suspected that it will stay horizontal, isn't it? But it does not. It always bend like this. It always make a slope with the horizon, and that angle which its slope makes with horizon is called angle of dip. Okay, you can see in this diagram, this is an example of deep needle. Okay, this is an example of deep needle, and this is a magnetic needle. Magnetic needle is exactly anchored at the center, so based on the gravity, if you need to apply gravity here, then it should have been balanced, isn't it? The needle should have been balanced. If you are only to apply gravity, the needle should have been balanced, but you can see the needle is not balanced. Okay, the north pole of the needle is slanted downward. The north pole of the needle is slanted downward, and south pole of needle is slanted upward. It indicates that you are in northern hemisphere. You are in northern hemisphere of Earth. If the blue or south pole of needle is slanted downward, then you are in southern hemisphere of the Earth. Okay, if the needle perfectly stays parallel to the ground, then you are at the equator, neither north nor south. Okay, north and south have equal influence, but if you are not in northern hemisphere, then the south magnetic south pole of Earth would be stronger, isn't it? The magnetic south pole would be stronger, so the magnetic north of needle would face downward. It would be attracted more. It would exert more force. Yes. Or if you are in southern hemisphere, then magnetic north pole would be stronger there. Yes. In that case, the south pole of magnetic needle would face downward, isn't it? So if you are in magnetic pole, say you are in magnetic north pole, in that case, that region is totally under the influence of the north pole. Yes, there would not be any influence of south pole. That's why the south pole of compass needle will face totally downward, making it right angle. Did you get it or not? Okay, Lara. Sorry. Okay, यो फिगर एकचोटि हेर्नु ल। यसमा तिम्रो अर्थको यो तिम्रो अर्थको म्याग्नेट होइन है, अर्थको म्याग्नेट जस्ट अपोजिट हुन्छ, तिमीलाई थाहा छ। यो अर्थको नर्थ पोल, यो अर्थको साउथ पोल हो, र म्याग्नेटिक पोल ठ्याक्कै अपोजिट हुन्छ हैन। यता म्याग्नेटको नर्थ हुन्छ, यता म्याग्नेटको साउथ हुन्छ। यो नर्थबाट यसरी म्याग्नेटिक लाइन अफ फोर्स दौडिरहेको छ, यसो दौडिरहेको छ, र यहाँ तिम्रो इक्वेटर यस्तो हुन्छ, यसरी इक्वेटर छ है। सपोज गर कि तिमी यो प्लेसमा छौ, तिमी यो ठाउँमा छौ भने ओके ल, सपोज गर तिमी यो ठाउँमा छौ भने यो ठाउँमा के हुन्छ त, अर्थको चाहिँ म्याग्नेटिक साउथ पोलको इन्फ्लुएन्स बढी छ नि हैन र। यसलाई करेक्सन गर्ने है, यो एकदमै कन्फ्युजिङ हुन्छ। म्याग्नेटिक साउथ र म्याग्नेटिक नर्थ। ओके यति गर्दिउँ अनि अलिक कन्फ्युजन दूर हुन्छ कि है, कन्फ्युजन हुन पाउँदैन। ओके ल, यो म्याग्नेटिक साउथ भयो हैन, अनि यो चाहिँ म्याग्नेटिक नर्थ भयो है। स्टिल पनि अझै पनि यहाँनिर लेभलिङ रङ छ र त, म्याग्नेटिक नर्थ लेखेको छ है। म्याग्नेटिक साउथ यहाँ छ र म्याग्नेटिक नर्थ यहाँ छ, र म्याग्नेटिक नर्थबाट चाहिँ यो लाइन अफ फोर्सेस रन भइराखेको छ हो। भने जब तिमी ठ्याक्कै इक्वेटरमा हुन्छौ, इक्वेटरमा के छ त, म्याग्नेटिक साउथ र म्याग्नेटिक नर्थको इन्फ्लुएन्स इक्वल पर्छ नि, इक्वल इन्फ्लुएन्स पर्ने भएर यहाँ हेर म्याग्नेटिक लाइन अफ फोर्स पनि ग्राउन्डसँग प्यारलल छ नि हैन। हो यो केसमा तिम्रो कम्पास झुन्डाए पनि के हुन्छ त, प्यारलल नै बस्छ है। तिमी यहाँ माथि आउँछौ भने यहाँ के छ त, म्याग्नेटिक साउथ पोलको इन्फ्लुएन्स बढी छ, यहाँ म्याग्नेटिक साउथ पोलको इन्फ्लुएन्स बढी छ, म्याग्नेटिक नर्थ पोलको इन्फ्लुएन्स कम छ। भनेपछि तिम्रो कम्पासको नर्थ पोल तल ग्राउन्डतिर झुक्ने भयो है। र यदि तिमी यहाँ आउँछौ भने यहाँ त के छ हेर, म्याग्नेटिक साउथ पोलको मात्रै इन्फ्लुएन्स छ नि हैन, यहाँ म्याग्नेटिक नर्थ पोलको इन्फ्लुएन्स छैन है। एज अ रिजल्ट कम्पासको निडल टोटली ग्राउन्डतिर झुक्छ के है। हेर्छौ? ओके लेट मी सी, लेट मी फाइन्ड इट आउट। deep needle at magnetic north pole. Okay, ल हेर न, देखिरहेछ? हेर के छ, तिम्रो म्याग्नेटिक पोलमा यो कम्पासको निडल यसरी पुरै पर्टिकल भएर बस्छ डिस्पाइट द इफेक्ट अफ ग्राभिटी है। ग्राभिटीले यसरी पर्टिकल भएर बस्न दिन्छ त? यदि ठ्याक्क बीचमा एङ्कर गरेको छ निडललाई भने दिँदैन नि, ग्राभिटीले त यसरी बस्नै दिँदैन, तर म्याग्नेटिक फिल्डले गर्दाखेरि यसरी बस्छ है। सो यो होराइजन भयो। सो डीप निडलले या फ्रीली सस्पेन्डेड म्याग्नेटले यो होराइजनसँग कति डिग्रीको एंगल बनाउँछ हो, त्यसलाई हामी के भन्छौं त? त्यसलाई हामी एंगल अफ डीप भन्छौं है, एंगल अफ डीप। ओके, अनि त्यसै अब डीप निडल एट म्याग्नेटिक इक्वेटर हेर है त कस्तो हुन्छ। लेट मी सी इफ देखाएन है। ओके, यो चाहिँ अलि क्लोजेस्ट रहेछ हेर, देखिया छ? ओके, यसको हेर त, यसको निडल अलमोस्ट होराइजोन्टल छ है, हैन र? हो, तिम्रो इक्वेटरतिर चाहिँ के हुन्छ त? इक्वेटरतिर चाहिँ निडल यसरी अलमोस्ट होराइजोन्टल भएर बस्छ। हेर त, यो डायग्राम हेर, यसमा अझै क्लियर छ। तिम्रो डिफ्रेन्ट पोजिसनमा जाँदाखेरि तिम्रो डीप निडल कसरी बस्छ त? भनेपछि यो डायग्रामले तिमीलाई के देखाउँछ त भन्दाखेरि, अघि यो डायग्रामले तिमीलाई के देखाउँछ त भन्दाखेरि, हेर यो डीप निडलको पोजिसनले म्याग्नेटिक लाइन अफ फोर्सलाई ट्रेस गरेको देखाउँछ। हो पनि डेफिनेटली डीप निडलको पोजिसनले म्याग्नेटिक लाइन अफ फोर्सलाई ट्रेस गर्छ है। र म्याग्नेटिक लाइन अफ फोर्स म्याग्नेटिक पोलमा के हुन्छ, म्याग्नेटिक लाइन अफ फोर्स पनि ठ्याक्क परपेन्डिकुलर हुन्छ नि, त्यसैले डीप निडल पनि परपेन्डिकुलर बस्छ हैन। यो प्लेसमा सर्टेन एंगल हुन्छ, त्यो एंगल चेन्ज हुन्छ है। हेर, यति कुरा बुझ्नु, यति कुरा बुझ्नु, डीप निडल always follows the magnetic line of force. Okay, this figure is more illustrative, so I'm going to copy it over here so that I can get it later as well. I won't lose the diagram. Okay, now you understand what is deep needle. हेर यो जुन magnetic line of force छ त्यो magnetic line of force को direction लाई नै यो deep needle ले follow गर्छ. त्यसैले चाहिँ magnetic equator मा deep needle ठ्याक्क parallel भएर बस्छ भने magnetic pole मा deep needle perpendicular भएर बस्छ, vertically बस्छ है. Okay, ल हेर. When a magnet needle is freely suspended, it forms certain angle with horizon. The angle so formed is called angle of dip or angle of inclination. Previously angle of declination. माथि के थियो? Angle of declination. यो के हो? Angle of inclination. It is measured by using an instrument called deep needle. यो जुन instrument देखाइएको छ यसलाई के भन्छ त? This is called deep needle. This instrument is called deep needle. It is important because by measuring angle of dip of a place is essential for navigation. Okay, so तिम्रो angle of dip ले तिमीलाई exactly कुन ठाउँमा छौ, यहाँ चाहिँ तिमी इक्वेटर बाट कति पर छौ भन्ने कुरा indicate गरे नि हैन र? Okay हैन? So navigation system मा angle of dip एकदमै important हुन्छ, very important है. navigation system मा angle of dip को एकदमै ठुलो इम्पोर्टेन्स हुन्छ. जस्तो तिम्रो एरोप्लेन भन, शिप हैन, अनि त्यसै तिम्रो मिसाइल, यिनीहरु सबै डिभाइसेसहरुमा नेभिगेसन सिस्टम त चाहियो नि. नत्र हामी जमिनमा गाडी चलाउँदाखेरि, बाइक चलाउँदाखेरि वरिपरिको सिनेरियो हेरेर ठाउँ थाहा पाउँछ, डाइरेक्सन थाहा पाउँछ. तर जब तिमी आकाशमा उडाइरहेको हुन्छौ प्लेन, यता हेर्यो स्काई, उता हेर्यो स्काई, कि त स्काई देखिन्छ कि त क्लाउड देखिन्छ हैन, तिमीले ठाउँ कसरी चिन्छौ त? There is no way of knowing the place. Okay, there is only one way, that is knowing the value of angle of inclination and angle of declination of that particular place. Okay, तिमीलाई चाहिँ त्यो कुनै ठाउँको angle of inclination or declination थाहा छ भने you will know where you are. Understood? Because यो दुईवटालाई combine गर्ने हो भने एउटा particular place को लागि angle of inclination and angle of declination को value एउटै मात्रै हुन्छ. It is just like coordinate के x axis र y axis भने जस्तै हो, x coordinate र y coordinate भने जस्तै हो. तिम्रो coordinates मा एउटा point को value एउटै मात्रै हुन्छ नि, युनिक हुन्छ नि हैन. त्यसै angle of inclination र angle of declination पनि particular place को लागि युनिक हुन्छ, एकदमै particular हुन्छ है त. Okay, so knowing the value of angle of inclination and angle of declination are important for navigation. Okay. Okay, next point, value of angle of dip at the magnetic equator is 0 degree because magnetic line of forces of the earth run parallel to the ground at the magnetic equator. You understand this point? This? Yes? Here at the magnetic equator, the angle of dip is 0 degree. That means it remains parallel to the ground. Okay, and then value of angle of dip at magnetic pole is 90 degree because magnetic line of force. Alright, yeah, text alright. Okay, there. Because magnetic line of forces of the earth run perpendicular to the ground at the magnetic pole. Etima ke confusion? I hope no confusion. Chata? Chain hai? ल ठीक छ. ल यदि तिमीलाई magnetic angle of inclination र angle of declination मा confusion छैन भने अब हामी हाम्रो last topic मा enter गरौँ, neutral point. Okay, तिमीले जब magnet मा यो magnet को field भयो, यो magnet को field मा या चाहिँ यो magnet को नजिकै एउटा compass त थाहा छ है, डाइरेक्सन फाइन्ड आउट गर्ने कम्पास लगेर राख्यो हैन. ल कम्पास को निडल लाई चाहिँ म जस्ट एउटा एरोले इन्डिकेट गर्छु है त. ओके, हो यसरी तिमीले कम्पास लगेर राख्यो भने यो कम्पास को नर्थले कसलाई रेस्पोन्स गर्छ त? यो कम्पास को नर्थले साउथलाई रेस्पोन्स गर्छ. यसलाई रोटेसन टुल युज गरौँ, सेन्टरमा राखेर sorry ल सेन्टरमा राखेर यसलाई रोटेट गर्यो भने यो के हुन्छ त यसरी घुम्छ हैन ठ्याक्क साउथमा ओके साउथ पोललाई यो कम्पासको निडलको नर्थ पोल के हुन्छ त यो साउथ पोलमा रेस्पोन्ड गर्छ है यो कम्पासलाई तिमीले यहाँबाट पर लग्यो माथि लग्यो हैन पर लग्यो भने के हुन्छ त स्टिल यो पोइन्ट आउट त हुन्छ नि यो कम्पासले स्टिल अझै पनि यो म्याग्नेटलाई रेस्पोन्ड गरेछ नि हैन र अझै माथि लग्यो भने अब के हुन्छ भने तिमी अर्थको म्याग्नेटिक फिल्डको रेस्पोन्समा पनि आउँछौ किनभने अर्थको लागि त नर्थ पोल यहाँ छ नि हैन र अर्थको नर्थ पोल यहाँ छ नि यहाँ भनौँ कि अर्थको म्याग्नेटिक साउथ पोल अफ अर्थको म्याग्नेटिक साउथ पोल यहाँ माथि छ नि हैन र भनेपछि यसको इन्फ्लुएन्स पनि त पर्छ होला नि यो कम्पास जब म्याग्नेटको एकदमै नजिकै थियो यो टोटली म्याग्नेटको इन्फ्लुएन्समा आयो हैन तर यो कम्पास म्याग्नेटबाट जति पर जान्छ त्यति नै अब यसमा अर्थको इन्फ्लुएन्स पर्छ हैन अर्थको इन्फ्लुएन्स परेपछि यो डेभिएट हुन थाल्छ यो कम्पास किनभने अर्थको इन्फ्लुएन्समा पनि घुम्छ नि हैन र अझै यहाँबाट तिमीले जति माथि लग्यो यो कम्पासबाट जति पर लग्यो त्यति नै यो चाहिँ अर्थको इन्फ्लुएन्स यसमा बढी पर्न जान्छ हैन र अर्थको इन्फ्लुएन्स जति बढी पर्यो त्यति नै यो के हुन्छ त यसको नर्थ पोल डेभिएट हुन्छ र सर्टेन ठाउँमा सर्टेन ठाउँ क्रस भइसकेपछि यो चाहिँ कम्प्लिटली अर्थको म्याग्नेटिक फिल्डको इन्फ्लुएन्समा आउँछ है कम्प्लिटली अर्थको म्याग्नेटिक फिल्डको इन्फ्लुएन्समा आउँछ हैन हो यस्तो भएपछि अब यसले के गर्छ त नर्थ पोलतिर यसरी इन्डिकेट गर्छ बुझ्यौ म्याग्नेटको नजिकै छ म्याग्नेटको इन्फ्लुएन्समा पर्छ अनि म्याग्नेटको इन्फ्लुएन्स या म्याग्नेटको फिल्ड भन्न बाहिर गएपछि अर्थको इन्फ्लुएन्समा पर्छ भनेपछि एउटा सर्टेन पोइन्ट हुन्छ यो दुईवटाको बीचमा यो म्याग्नेटको फिल्डमा एउटा सर्टेन पोइन्ट हुन्छ जहाँ चाहिँ यसले यो कम्पास निडलले कुनै पनि पार्टिकुलर डाइरेक्सन देखाउन सक्दैन समटाइम्स इट कम्स अन्डर इन्फ्लुएन्स अफ म्याग्नेट sometimes it comes under influence of earth because at that particular point the magnetic field of earth and the magnet are equal okay at that particular point the magnetic field of the earth and the magnet are equal but they are opposite okay so at that particular point the compass needle cannot show any direction it cannot point to any direction and that point is known as neutral point understood that point is known as neutral point so neutral point is a point in magnetic field it is a point in magnetic field where its magnetic field is cancelled by another magnetic field in opposite direction and in general case magnetic field of a compass is cancelled by the magnetic field of the earth okay got it so a compass does not show any response at the neutral point जब compass neutral point मा पुग्छ त्यहाँनिर उसले कसैलाई पनि रेस्पोन्ड गर्न सक्दैन न त अर्थलाई न त म्याग्नेटलाई okay so neutral point you understand what it is now the neutral point position of neutral point differs on the basis of the placement of magnet okay suppose that okay this is the magnetic line of force of earth okay this is the magnetic line of force of earth and at a particular place the magnetic line of force can be represented by straight line in case of earth because it is too large isn't it is it or not it is too large okay and this is magnet and these are the magnetic line of force and you can see magnetic north is here magnetic north of the earth okay magnetic north of the earth is here and magnetic south is here okay so the line of force is moving upward yes if you place the magnet in this within this magnetic field of earth, then this magnetic line of force, they interact with each other. And you know that magnetic line of force never intersect, and they always repel each other. See here, in how many points you can see the magnetic line of forces are intersecting? It does not occur, it does not happen. So because of that interaction, the magnetic field of earth gets repelled, and it bends like this. See, this is the magnetic field of earth. It is bending, isn't it? It is bending, yes, like this. And the magnetic field of magnet, it is as usual. See, this one as usual, and this one is also as usual, which has merged to the magnetic field of earth, this one. Okay. However, at this particular point, you can see the magnetic field of earth is moving upward. Yes, magnetic field of earth is moving upward, but magnetic field of the magnet is moving downward at this particular point. At this point, you can see both the magnetic fields are moving upward. Yes, so there is no cancellation of magnetic field. Okay, both the magnetic fields are moving upward, but at this particular point, you can see magnetic field of earth is moving upward and that of magnet is moving downward. So at the point where both the magnetic fields are equal, they get cancelled out, because as I have told you, they are acting in opposite direction. If you move up from this point, then you are under the influence of magnet. Okay, you are under the influence of magnet. If you move below this point, you are under the influence of earth. But exactly at this point, you are neither under the influence of earth nor the magnet. Or at the same time, you can say you are under the influence of both magnet and the earth. So your compass will not show any direction at this point. Your compass will not show any direction at this point. So this is the neutral point. Okay, and here in upper position also there is a neutral point, because above the magnet, the magnetic line of force of the magnet is moving downward. See, it moves like this, means here the magnetic line of force of magnet is moving downward, but magnetic line of force of earth is moving upward. Okay, so at this point also, magnetic line of force of magnet and earth, they are moving in opposite direction. Okay, and since they are equal in quantity, they cancel out each other. So here also you obtain a neutral point. Here also you obtain a neutral point. So nowadays, for a magnet there is always two neutral points, and this is the case when south pole of magnet is pointed face toward north pole. Magnetic south means actual north pole. Don't be confused. Okay, look here, don't be confused. Magnetic south means actual north. Okay, this is the response when south pole of magnet is facing toward actual north pole. Okay, so if you are asked to show the neutral point when south pole of magnet is facing toward north, then this is the diagram you need to draw, not this. This is just for your understanding. This is for clarification. Okay, because I already told you, magnetic line of force, they don't intersect. If you draw like this, it would be wrong. And here also you can see at this particular point, at the central part of magnet, the line of force of magnet is moving downward, line of force of earth is moving upward. Yes, and here also the same thing, isn't it? Okay, so that gives this overall interaction of magnetic field of magnet and the earth gives this kind of magnetic field. Any confusion? Okay, so let's go to next case, case number 2, in which the north pole of magnet is facing toward the actual north. Okay, north pole of magnet is facing toward actual north. In this case, just above and below the magnet, you can see the line of force are moving in the same direction. And अघिको केसमा के थियो त हेर त म्याग्नेटको ठिक तल र माथि के थियो त लाइन अफ फोर्स अपोजिट थियो नि म्याग्नेटको लाइन अफ फोर्स तल छ है तलतिर आएको छ अर्थको म्याग्नेटिक लाइन अफ फोर्स माथितिर गएको छ अब यहाँ के छ त म्याग्नेटको ठिक तल र माथि म्याग्नेटिक लाइन अफ फोर्स कोइन्साइड भएको छ हैन हेर त म्याग्नेटको पनि लाइन अफ फोर्स माथि नै गएको छ अर्थको पनि लाइन अफ फोर्स माथि नै गएको छ किन भन्दाखेरि अर्थको म्याग्नेट जुन पोजिसनमा छ हाम्रो म्याग्नेट पनि त्यही पोजिसनमा छ एउटै पोजिसनमा छ यहाँ तल पनि हेर दुवैको म्याग्नेटिक फिल्ड अपवर्ड पोजिसनमा गएको छ माथितिर आएको छ हैन तर अब यो म्याग्नेटको म्याग्नेटिक फिल्ड यसरी घुमेर आउने हो नि हैन र हो यसरी घुमेर आउँदाखेरि म्याग्नेटको दुवै साइडमा चाहिँ कन्फ्लिक्ट पास हेर लाइन अफ फोर्स अफ म्याग्नेट इज मुभिङ डाउनवर्ड लाइन अफ फोर्स अफ अर्थ इज मुभिङ अपवर्ड जबकि यो केसमा के थियो त म्याग्नेटको दुईटा साइडमा लाइन अफ फोर्स एउटै डाइरेक्सनमा मुभ गरेको छ हैन भनेपछि यहाँ पनि यो म्याग्नेटिक लाइन अफ फोर्सहरुको बीचमा जुन इन्टरेक्सन हुन्छ म्याग्नेटिक लाइन अफ फोर्स अफ अर्थ एन्ड म्याग्नेटिक लाइन अफ फोर्स अफ magnet they interact with each other okay they interact with each other because you know they repel each other magnetic line of forces repel each other because of that a new kind of field is created okay and in this field neutral point is found on both sides of magnet not on the upper and lower point but on the both side of magnet okay so at this point you can see the magnetic line of force of magnet is moving downward and that of earth is moving upward so since they are equal in magnitude at this particular point the magnet does not show any particular direction okay understood this at this point the magnetic field of magnet and earth are equal in magnitude but opposite in direction so they cancel out each other so the compass is in the influence of both magnet and earth so it does not show any particular direction at this point okay but if you move slightly to this side then you will be under the influence of magnet if you move to this side you will be under the influence of earth but exactly at this point you are under the influence of both magnet and earth okay this is like a boundary so you get neutral point here and here understood okay so this is the case when okay you need to write this when north pole of the magnet is pointing toward geographic north pole of the earth okay and this is the case when just the opposite north pole of the magnet okay when north pole of the magnet is pointing toward geographic south pole okay okay you need to get these two very clearly तिमीहरुलाई न्यूट्रल पॉइंट बाट सोध्ने क्वेशन भनेको तीनवटा मात्रै छ व्हाट इज न्यूट्रल पॉइंट है याद राख व्हाट इज न्यूट्रल पॉइंट एउटा क्वेशन यो भयो अनि अर्को diagrammatically show the neutral point of magnet when north pole of magnet is facing toward geographic south pole okay यति भन्दाखेरि पनि एक्सरसाइज गर्दाखेरि प्राय स्टुडेन्टहरु चाहिँ यहाँनिर कन्फ्युज नै हुन्छ क्वेशनले भन्छ diagrammatically show the neutral point of magnet when north pole of magnet is pointing toward geographic south pole भने हुन्छ अनि मैले सर कुन चाहिँ डायग्राम बनाउने भनेर सोधिराखेकै हुन्छ है त ल यो दुईवटा डायग्राम कपी गर्नु किनभने तिम्रो भने मैले यो पार्टबाट सोध्ने क्वेशन नै त्यही तीनटा मात्रै हो ओके व्हाट इज न्यूट्रल पॉइंट हैन diagrammatically show the neutral point of magnet when the north pole of magnet is pointing toward geographic south pole or तिमीलाई सिम्पली साउथ पोल मात्रै पनि साउथ मात्रै पनि भन्छ है जियोग्राफिक साउथ भन्दैन किनभने हाम्रो डेली ल्याङ्ग्वेजमा जनरल लाइफमा नर्थ एलाई साउथ एलाई भनिन्छ नि हैन त्यसैले जियोग्राफिक भन्ने वर्ड खासै क्वेशनले दिदैन र अर्को क्वेशन के हो त diagrammatically show the neutral point of magnet. Diagrammatically show the neutral point of magnet when north pole of magnet is pointing toward geographic north pole of the earth. And magnet को north से north में फर्किँदाखेरि त्यसको न्यूट्रल पोइन्ट कहाँ हुन्छ एउटा क्वेशन र म्याग्नेट को नर्थ पोल साउथ मा फर्किँदाखेरि न्यूट्रल पोइन्ट कहाँ हुन्छ दुईटा क्वेशन भयो अनि त्यसपछि डिफाइन न्यूट्रल पोइन्ट यो तीनवटा क्वेशन यो सेक्सन बाट सोधिने हैन ओके so with this much your lesson is concluded and with this lesson your physics part of science is concluded. Okay, in our next class we will start biology class, we will start biology part. Okay, but at the same time you have to do the exercise of this lesson from the book you have, whichever publication does not matter, whichever publication book you have, you can do the exercise from that book. Okay, and then send me the photograph of that exercise through messenger. I will check it there. Okay, that's all for today. Thank you class.